9-6 is dilations. What do you think of when you hear dilation? To dilate. Oh, someone giving birth. Yes, that's not the one I usually hear, but yes. Yeah, your pupils, okay? So we'll go with that one since it's a little less graphic. Your pupils, right, dilate, open and close. So if you shine a light on someone's eyeballs, what happens to their pupil? It gets smaller because you don't want to let as much light in, right? And then you go into a dark room and they get bigger to try and get the light in. That is dilation. That is a dilation. So what's happening is something is changing proportionally, okay? Which is what we're going to talk about today. With dilations, you will have a center of dilation. Okay, which they're going to call C for that. And you will have a scale factor, because like I said, it changes proportionally. They call this scale factor N, okay? And it has to be that N is greater than 0. In other words, you can't have a negative scale factor or a 0 scale factor. 0 would mean your figure didn't change size. So it has to be a number greater than 0 to be your scale factor. And then they'll write it like this. So with all the ones we've done so far, it's been a translation was T, reflection was a capital R, rotation was a lowercase r, dilation is a capital D. So they will write it like this. It's a dilation, and then the subscript for this one is going to be your scale factor followed by the point that you dilate around, okay? So your center of dilation. Okay, so that's the notation for it. When you write the rule, this is how your rule should look. I'll show you an example later of where it's not always going to look just like that, but for the most part, that's how the rule should be written. All right, here's what you're going to do. I'm going to draw you a picture of a dilation, so we have the pieces of it to discuss. And I'm kind of doing this backwards. I'm going to draw the lines first, and then I'm going to draw the figures that go with it, so bear with me. Just because it makes my pictures make more sense. Oops. All right, so let's say our initial, nope, this is actually our image. This is our final result, and then I'll draw the pre-image after that. So if you have a triangle, okay, this is P prime. You doing all right back there? This is Q prime. This is R prime. Okay, so if that is my image, that's my final result. This is what has been dilated. The thing that we dilated, we'll say, is this picture. All right, so this is P, Q, and R. So here's the thing. The point that it stems from, the point where we are dilating from, that is my C. That's my center of dilation that we were talking about before. The length of C prime, R prime, so if I do CR prime, the way we can figure out that distance is by multiplying the distance to C, or the distance of CR by the scale factor. So I'm going to take that N, the scale factor, and multiply it by CR, and that will get me my C prime, R prime. Okay, another way you could think of that then is if I divide both sides by CR right now, I would get that my scale factor is equal to CR prime over CR, right? So the distance here over the distance here gets me my scale factor, okay? The distance of the image over the distance of the pre-image gets me my scale factor. And we'll talk about that right now, but that's just kind of the basic of it. So what we can say with these two triangles is triangle PQR. Do you remember what the tilde means? Similar. So we're saying triangle PQR here is similar to triangle P prime, Q prime, R prime. They are proportional. The sides will be proportional, okay? All right, so when it comes to scale factor, just make sure that, we'll just go up here, okay? When we're talking scale factor, it's always gonna be the image over the pre-image, okay? Remember, image is the one that has the prime, okay? So it's always the prime over the non-prime lettering. So here's what we're gonna do with that. I'm gonna give you a couple pictures right now, and we're gonna talk about the main things that you're gonna have to do with a dilation with these pictures, scale factor being one of them, okay? So here is our first picture. Actually, let me write this first. There's two parts to, not two parts. There's two things you have to determine, one of which is it an enlargement or is it a reduction? Okay, so we're gonna just talk about enlargement and reduction, and then we'll actually draw the pictures and see what it is. So with a dilation, an enlargement means your pre-image is here, and then it grew, it got bigger, right? It dilated and got bigger. When that happens, that means our N, our scale factor, is greater than 1. Okay, so if the scale factor is greater than 1, then that dilation was an enlargement. Okay, whereas on the opposite end, if my scale factor, so if N, my scale factor, is between 0 and 1, then it's a reduction, okay? Now think about that. You can't have a negative, right? I feel like a lot of times people think, oh, if it's a positive number, it's an enlargement. If it's a negative, it's a reduction. It doesn't work that way. If I'm doing an enlargement, right, let's say my scale factor is 2. That means I'm doubling my figure. Whereas if I do a reduction, my scale factor could be 1/2, right? I'm cutting that figure in half. So if it's a fraction, if it's between 0 and 1, then it's going to be a reduction. If it's more than 1, it's an enlargement. It got blown up somehow.
Then what would you call 1?
Congruent, right? It didn't dilate at all then, because dilations have to grow or shrink. If it stays the same, you just have congruent figures, so it would be a slide or a flip or a turn. It would be one of our other ones that we did, okay? It's a good question. Okay, so let me draw you a picture, a couple pictures here, and we're going to talk enlargement, reduction, scale factor, what we're all working with at this. All right, let's say you have a parallelogram and a parallelogram. This is A, B, C, and D. And this is B prime, C prime, and D prime. And then we are told that CD has a length of 2 and C prime, D prime has a length of 4. Okay, so first of all, can you tell me, we have all these points, right? Can you tell me what the point of dilation is? Where are these figures both dilating? Where is the one figure dilating from? Do you see it? It's point A, right? The original, the ABCD, is at point A there, and then everything grows from A. It expands from there. So A is my center of dilation. Okay. What is my pre-image and what is my image? What figure did we start with? The smaller one, right? The ABCD. So my image is A, B prime, C prime, D prime. Okay? Is that an enlargement or a reduction? Enlargement. We started small and we got bigger. Okay? So that is an enlargement. And then the last thing I want to know is, what is my scale factor? Now go back up here to where we talked about scale factor, right? When you do your scale factor, it is always image over pre-image. So do you have numbers for these figures? You do. You have a 2 and you have a 4, right? Which one goes on top? The 4. It's the image, right? C prime, D prime over the original. So it's 4 over 2, which would reduce to 2 to 1. So my scale factor is 2 to 1. Do you know what that means for that figure? It doubled, right? It was a scale factor of 2, so my original figure doubled. Does that make sense? Okay, so it's an enlargement with a scale factor of 2. Okay, what about this one? So if E prime H prime has a length of 2 and EH has a length of 8, can you tell me your center of dilation? Where were we dilating from, essentially? X. Okay, so your center of dilation is X. Okay, is this an enlargement or a reduction? This is a reduction because your original, your EFGH is the big one. The prime is the small one, so this is a reduction. So think about that with your scale factor. When it's a reduction, your scale factor has to be a number between 0 and 1. Okay? So that's a good check for you if you're doing the setup right. What would your scale factor be? Right, you would put the 2 over the 8. Okay, it's the image over the pre-image, oops, and then reduce that. So 2 over 8 is 1 over 4. Okay. So with a scale factor of 1 to 4, that means my image is 1/4 the size of my pre-image, right? It shrunk by 1/4. Well, it shrunk to 1/4 of the size. Does that make sense? Okay. All right, let's try one of these. Example 1 here. Let's say we have a triangle. And this is A, B, B prime, C, and C prime. All right, here's the question. Is this an enlargement or a reduction? Okay, so that's your first question, enlargement or reduction. And then what's the scale factor? Okay, so let's start with enlargement or reduction. I feel like most of the time people get this part right. It's usually the scale factor that gives people trouble. So if you can just remember that an enlargement has a scale factor that is more than 1, whereas a reduction has a scale factor between 0 and 1, okay? What would you say this is? This is an enlargement because you started, your pre-image is this triangle, okay? Your image, and this one you have to be a little bit careful with, your image is this triangle, right? It's not this piece, it's the whole triangle. So this is an enlargement, which means what about my scale factor? It has to be between 0 and 1 or more than 1? More than 1, okay. Now be careful with our scale factor here. You're doing image over pre-image, right? That was the setup we said for scale factor. What's my image length? It's 9, right? You have to take the 3 and the 6 together because we need this whole side. Okay, so the image is 9. What was the pre-image length? 3. So 9 to 3, or 3 to 1, or you could just call that 3 technically. So my scale factor is either 3 to 1 or 3. They're both fine. But it is an enlargement with a scale factor of 3. What's my center of dilation? A would be the center of dilation. Okay. Questions on that? Okay. Then we're going to move into the coordinate plane. So when you do a dilation in the coordinate plane, it's actually, it maybe looks like it would be hard to do. It really is not hard to do if you use the numbers. So I'm going to show you that right now. One thing to note with this book, every single dilation that you do in the coordinate plane will have a center of dilation of 0, 0. Okay, you will never dilate from a different point. They're not fun to dilate from other points. But when you dilate from 0, 0, they're very simple. Okay, so you will always dilate from 0, 0. Here's the kind of the formula that you can follow. So n is your scale factor, right? So it's a dilation of n for whatever your x and y would be. What you do is you just multiply the scale factor by each of those numbers. So I would take n times x here and n times y here, and that will be my dilation rule. So for this problem, let's say I tell you to find the vertices for a dilation of 2 of triangle LMN. Okay? So I'm going to give you triangle LMN, and I'm going to give you the actual numbers, but we're also going to graph it. So L is the point -3, -2. M is the point 1, -2. And N is the point 2, 3. Okay, so let's plot those. -3, -2. 1, -2, and 2, 3. Okay, so this is our pre-image. We're going to draw that triangle in. What they're asking us to do is dilate with a scale factor of 2. So if you look up here, we said we just take the scale factor and we multiply it by our x and by our y. So that means that L prime would be what? -6, -4, right? We're just going to take this -3 and -2 and multiply it by 2. So it's going to be -6, -4. Okay, that's L prime. So what would M prime be? 2, -4, right? I take that 2 and I multiply by both those things. So it'd be 2, -4. Okay. And then the last one, N prime? 4, 6. You're just doubling the 2 and the 3. Okay? So if we plot those, L prime, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. So here's L prime. M prime is 2, 1, 2, 3, 4. And then N prime is 4, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Okay, so if I draw that triangle in, it looks something like that. Notice you can kind of tell just with the look of it that it's dilating from 0, 0, right? This is our point, our center of dilation, and it is growing from there. Questions on that? Okay, so you're literally just taking the coordinates and multiplying by whatever number our n is. Whatever that scale factor is, that's what you're going to multiply by. So if it's 1/2, you cut it in half, right? Multiply by 1/2 or divide by 2. You could think of it that way. Okay, last thing. And then we're done. Did I move too quickly for you? Okay, let's say someone has a photo that is 4 inches high by 6 inches wide. Okay, and she's going to enlarge it by a scale factor of 1.25. So she wants it 1.25 times larger, right? She's enlarging it. Can you tell me what her new dimensions would be? Or how to find them? You just multiply each one. Okay, so this, again, very simple. You're just multiplying by a scale factor, which is exactly what you just did on the dilation. So 4 times 1.25 comes out to 5 inches. And then 6 times 1.25 comes out to 7.5 inches. So the question is, what is the size of the new picture? Those are your new dimensions. So it would be a 5-inch by 7.5-inch picture. Okay, so if they give you a scale factor, chances are you are multiplying your numbers by that scale factor that they gave you. Questions on that? Okay, that is dilation.